Hello everyone, I'm standing in the center of Europe, staring at the wreckage of a crime scene, of a collision. The Swiss Alps are what happens when Africa crashes into Europe. It is violent and it is massive. But 18,000 kilometers away, on the exact opposite side of the planet, there is a mirror image, the Southern Alps of New Zealand. They look the same, they're chemically similar, but according to the geography we learned in school, they shouldn't be there. For centuries, New Zealand was a geological anomaly. Too big to be a volcanic island chain like Hawaii, and too isolated to be a stray fragment of Australia. It broke the rules. So why is there a continental scale mountain range in the middle of the deep ocean? The answer is that what we see is just a penthouse suite. New Zealand isn't an island, it's the visible tip of a sunken empire, a lost continent that has been hiding in plain sight for 375 years. This is the story of Zealandia. But before we find the continent, we have to ask a question that sounds simple, but is actually quite difficult. What is a continent? In 2017, a team of geologists led by Nick Mortimer published a paper that redefined the map. They argued that continent isn't a geography word, it's a geology word. To join the club, you need 4 things. 1. You need high elevation relative to the ocean floor. Geologically, high doesn't mean above the waves, it means bathymetric prominence. The land has to stand distinctly above the surrounding abyssal plains of the deep ocean. 2. You need a diversity of rocks. The ocean floor is chemically monotonous, meaning almost entirely dark, heavy basalt. But continents are a complex chemical cocktail. You need felsic rocks, silica-rich stuff like granite, and metamorphic rocks like schist, the continental fingerprint. 3. You need a thick crust. While the ocean floor is a thin skin, only about 7 kilometers deep, a typical continent is a massive slab. And 4, you need well-defined limits and a large area. To be a continent, you can't be a collection of isolated islands, you have to be a continuous tectonic province. Zealandia had the rocks, it had the thickness, and it had the limits, but for a long time we thought it failed the first test. It just wasn't high enough. Or was it? The average depth of the Pacific Ocean is 4,000 meters. This is the abyssal plain. It is made of dense, heavy, oceanic crust that sinks deep into the mantle. Think of the Earth's crust like boats floating on the mantle. Oceanic crust is dense. It rides slow in the water. Now continental crust, on the other hand, is lighter, throatier. It floats high. But here is where it gets strange. Since we couldn't see the rock of Zealandia because of the water, we stopped looking at the rock and started measuring the water itself. Massive objects have gravity. A huge underwater continent pulls the ocean towards it, piling the water up like a hill. The sea surface over Zealandia is actually higher than the sea surface over the deep Pacific. We use satellites to measure this hill of water. By mapping the bulge, we could see the shape of the ghost beneath. The data revealed a continuous, coherent landmass of 4.9 million square kilometers. Imagine, that's bigger than India, and it's half of the size of Australia. It is not a collection of islands, it's a single plate of continental crust. To prove that this was a continent, we needed physical evidence that this land was once dry. For this reason, in 2017, Expedition 371 sailed into the Tasman Sea and punched a hole 860 meters into the seabed to collect some samples. If Zealandia was just a stretched piece of ocean floor, they should have found marine fossils, shark teeth, plankton, but instead they found a time capsule. So now buried under millions of years of limestone, what they found was pollen. Yes, specifically Nothofagus, the southern beech tree. They also found spores of land ferns and lipids from soil bacteria. Woohoo! This implies something profound. 50 million years ago, this wasn't a sunken plateau. It was a land bridge, a warm subtropical rainforest connecting New Zealand to New Caledonia and Australia. But then the water rose. As the continent drowned, it became a biological life raft. Imagine the final scene of Titanic, but with continents and animals, kind of. Animals that walked here from Australia were suddenly trapped on drinking islands, and this isolation is why New Zealand is the bird capital of the world. When you have a continent's worth of animals crammed onto an island's worth of land, evolution goes into overdrive. Flightless birds like the moa and the kiwi are the refugees of a drowning empire. They are the biological echo of a geological disaster. So, why did it sink? Why is 94% of this continent underwater? To understand that, we have to understand ductile extension. Imagine the Earth's crust is a pizza dough. When it's in a bowl, it's thick and it's tall. But 80 million years ago, the mantle beneath the supercontinent Gondwana got hot. Really hot. As Australia and Zealandia started to rip apart, the crust was heated and stretched. It thinned out. Now, normal continents are about 35 to 40 kilometers thick. Zealandia was stretched until it was only 20 kilometers thick. It's simple buoyancy or isostasy. Because Zealandia became the thinnest continent on Earth, it naturally sank below the waves. It didn't disappear fully, you can say, it just lowered its profile. But the skeptics had one last weapon. They said, real continents, they have a heart. What they meant was a craton, an ancient stable nucleus of rock that is billions of years old. And Zealandia looked like it was made out of young, recycled junk. Enter Dr. Rose Turnbull. In 2021, she analyzed granite samples from the South Island. And she wasn't looking at the rock itself, she was looking inside the zircons, tiny crystals that survive virtually anything. Think of a granite rock like a modern brick wall. It was built recently. But now imagine finding inside of that wall a Roman coin. The wall itself is new, but the coin tells you that there is an ancient history that is buried underneath. The data proved that deep beneath the younger crust, Zealandia had a root of Precambrian rock, a piece of the supercontinent Rodinia, which is over 1 billion years old. Now, it has a craton, it has a heart, and with this, the debate was over. By measuring isotopes of hafnium and oxygen inside of these crystal coins, she found a ghost signal. The zircons had grown around a seed of much older rock. So, we have a sunken, thin, ancient continent. Why is any of it above water today? Why can we stand here? Because the Earth never stops moving. About 25 million years ago, the Pacific plate stopped just drifting and started colliding, and it rammed into the Australian plate. This collision acted like a snowplow. It caught the sunken, thin crust of Zealandia and forced it upwards. The Southern Alps are rising at the rate of 10 millimeters a year, which geologically is light speed. It is a violent resurrection. Earthquakes like Gai Goura in 2016 are just growing pains. Zealandia is the only continent that is mostly drowned, yet violently alive. The story of Zealandia is about the blind spots in our own perspective. If we can miss an entire continent for 375 years, simply because it was slightly too deep, well, what else is hiding in the blue spaces of our maps? I'm Pascal. Thanks for exploring.